Point a camera at a small square of black and white boxes and a website opens. No typing, no wires. The whole message is sitting right there, printed on paper in plain sight. A QR code can be torn, smudged, even partly covered, and it still works. How? Today we slice one open, square by square, and read it the way your phone does. Up close, a QR code is just a grid. Each tiny square is called a module. A dark module means 1. A light module means 0. That is the entire alphabet. The smallest codes are 21 modules across, the biggest are 177. String the squares together and you get a long line of ones and zeros, the same binary language every computer speaks. The picture is not a picture at all. It is data, frozen in ink. Look at the 3 big squares in the corners. Those are finder patterns, and they solve the first problem. Where is the code? Each one is a bullseye, dark, light, dark, in a strict ratio of 1, 1, 3, 1, 1. Scan any line through it at any angle, and that ratio holds. Your phone hunts for that signature in every frame. 3 corners found, 1 corner empty. That asymmetry tells the phone which way is up. Between 2 of the corner squares runs a thin dotted line, dark, light, like a ruler printed into the code. This is the timing pattern. It tells the software exactly how wide one module is and how many fit per row. Larger codes add small alignment squares scattered across the middle. If the paper is bent or the camera tilts, those anchors let the software stretch the warped image back into a perfect grid. Now the message itself. Say it is a web address. Each letter becomes a number, each number becomes 8 bits. 8 dark or light squares. The bits are laid into the grid in a zigzag, starting at the bottom right corner, climbing up 2 columns at a time, then snaking back down. It threads around the finder patterns and the timing lines, filling every spare cell. Your URL is literally woven through the picture, like thread through cloth. Here is the quiet genius. Before printing, the code adds extra squares of pure math, made with a method called Reed-Solomon error correction, the same trick used on CDs and deep space probes. These backup squares can rebuild missing data. At the highest setting, you can destroy nearly 30% of the code, and it still reads perfectly. That is why a logo can sit right in the middle. The logo is damage. The math just shrugs and repairs it. One last step before printing. If the data happens to form big blobs of dark or fake bullseyes, cameras get confused. So the code is masked. A mask is a checkerboard-style pattern layered over the data, flipping certain squares from dark to light and back. The encoder tries 8 different masks, scores each one for readability, and keeps the winner. A tiny label near the corner records which mask was used, so your phone can flip the squares back. Now flip to the phone side. Your camera does not see squares. It sees millions of pixels in a messy photo, shadows, glare, a tilted angle. The software converts the image to pure black and white, then sweeps it for that 1:1:3:1:1 bullseye ratio. Found once, twice, 3 times, the corners lock in. From 3 known corners, the software computes the exact tilt and stretch of the code and mathematically flattens the photo as if you had scanned it head-on. With the grid flattened, the phone samples the center of every module. Dark becomes 1, light becomes 0. It reads the format strip first, learns which mask was used, and unflips the masked squares. Then it walks the same zigzag path the encoder used, bottom right, up, over, down, collecting bits into bytes. Error correction runs next, comparing the data against the backup math, repairing any squares lost to glare or a smudged thumb. Out comes the original message, bit for bit. How much fits inside? QR codes come in 40 sizes, called versions. Version 1 is 21 modules across and holds a few dozen characters. Version 40 is a dense field of 30,000 squares, holding over 4,000 letters, or 7,000 digits. There is a trade though. More error correction means fewer squares left for your message. Designers pick the balance. A poster in a clean office needs less armor than a sticker on a rainy street pole. The QR code was invented in 1994 at a Japanese factory by an engineer tracking car parts. Barcodes were too slow, one thin strip, one direction, a few dozen characters at best. His grid stored data in 2 dimensions, read from any angle, in a fraction of a second. QR stands for quick response. The company gave the patent away for free, and that single decision is why the squares now live on menus, tickets, and boarding passes everywhere. Run the whole chain one more time. A message becomes ones and zeros. The bits are woven into a grid in a zigzag, wrapped in Reed-Solomon backup math, and cleaned up with a mask. Finder patterns mark the corners. Timing and alignment patterns hold the grid straight. Your camera spots the bullseyes, flattens the photo, removes the mask, walks the zigzag, repairs the damage, and hands you the message. Print to phone, the entire journey takes under a second. Next time a menu hands you a small square of static, look closer. There is a map in the corners, a ruler along the edge, a message woven through the middle, and enough spare math to survive a coffee stain. We slice open one everyday machine in every episode. Subscribe and the next Cutaway lands in your feed. Thanks for watching The Cutaway.